Hello, good morning, and welcome back to Refactoring Bitcoin. In the last month, I have been fine-tuning the generic test discovery feature for CMake. It is now in a shape that I really like, and it has been merged, which means the upcoming release, CMake version 4.4, will provide a new built-in command called discover tests. How to use that command and what the actual problem is that this command solves, I will now present in a series of short videos where I will show how we are going to use that command in the Bitcoin project. But I want to first start with very basic. I want to show the fundamentals of testing in the CMake project. So here we have an empty project called example. And in this project, I want to add a library. So I say add library, and I call this library mylib. And for the sake of the example, I will make this an interface library. But you can imagine in a real project, this will be a huge library. Let's say we build it as a static library, and it will contain lots and lots of source files. Whenever I create a library, I also create an alias library for that library. So I write add library, and I call this my : lib. And it's an alias to this mylib. And what I do here is this mylib without the : this will be the target name for myself. This is what I use to add source files to the target or link libraries to the target, etc. The naming syntax with : will be the interface that clients will use. So clients that use my library will use this my : lib. And when I export the library, I will make sure that clients that import the package will use exactly this naming convention as well. But in this example here, I will not show how to export it. I will just show how to use it inside the project when I link the tests against it. So I want to add the tests in a separate directory. So I create a new folder here and I call it tests. Okay. And in my main CMake list.txt file, I call add subdirectory tests. Okay. And in this tests directory, of course, I also need to add a CMake list.txt file. Okay, this is where I will define the tests. So for the tests, I create a source file and I call this test1.cpp. And in this test, now you have to imagine again, this is where I will include the header files of my library. And then I will have a main function. And inside that function, I will set up classes of the library, etc., in core functions of it. And if those functions succeed, I will return a success value. That means I will return 0. And if the test fails, it will crash or return a non-zero value. So I want to present a succeeding test. So therefore, I simply return 0. And I will also show a second test that fails. So I will duplicate this file here and I call this test2. And in here, I just return -1. So this will be a failing test. I close those two. And in the CMake list.txt file, I first have to create an executable target for the test. So I run add executable. So the name of the executable will be test1, and the source file of the executable will be test1.cpp. And now I want to link the library under test. So that means I run target link libraries. The name of the targets that I'm linking libraries against is my test executable, test1. The dependencies will be private. Cannot type, huh? What is here? Private, and I link the library under test, which is my : lib. Okay, and I want to add the test, so I call add test, and I give the name of the test using the name argument, and I call this test test1. And you don't want to confuse that test name with the target name, okay? So what I provide here is called the same, but it has got nothing to do with the target actually. Then the command of the tests, and this is where I now provide the name of the target, which is also test1. Okay, and I want to duplicate that code for test2. Let's see, copy and paste. So I create a library, I create an executable, sorry, test2. The source file will be test2. I link my library against test2. I add a test with the name test2, and the command will be the target test2. Okay, you see already that's duplicated. We will have a look at this in a minute. So first we want to try building this. So we create a build directory, create the build directory, cd into the build directory, and now we run CMake ... And I see I have a typo here. Link, of course. Link libraries. I run configure again, and now configuration succeeds. I want to build, and my test executables have been built. Now let's see what happens when I run ctest. It tells me test configuration file not found. And this is because we did not enable testing. So we have to add in the top level CMake list txt file, we have to add this command called enable testing. Okay, and now if we rerun the configuration and rerun the tests, now we see that our tests are executed, test 1 passes, and test 2 fails. And this is exactly what we expected. Okay, so this is cool. But now let's look at the tests here again. We said that we imagine in a real project, this will be a huge library with, we don't not only have 2 tests, we have probably hundreds of those. And if we have to repeat this code here in the CMake list txt file for each test, that's repetitive. And your instinct as a programmer tells you that you want to generalize that and probably extract that into a common function. Okay, because in each block for a test, you see, for example, test 1 is repeated 1, 2, 3, 4, 5 times. So you can imagine you would probably want to extract that into a custom function that has a single argument, which is just the name of the test. And then inside the function, you will add the executable with the source file, link the libraries under test, and then call the add test function. Okay. Another approach would be to define the test names in a CMake list, and then loop over that list and execute this code here inside the loop body, which will be roughly the same. But there is a more fundamental problem with those approaches, with the approach of having an individual source file per test, and that is the following. Imagine we have this huge library, and we want to make a change to the implementation of the library, and not a header file, not something that requires recompiling the whole library, but really just we want to make change inside the implementation, inside a single source file, inside a function. So when we want to rerun rebuilds, this really builds just a single source. And so it recompiles a single source file, and then it runs the archive step for the library, but then it needs to relink those hundreds of test executables. Okay, so those are many build steps necessary, so that will take time, but it also takes memory space. If our library is large, then, and if we statically link that, then the size of the library will contribute to each test executable, and that requires disk space, of course, right? So it takes time to build those libraries and wastes disk space. Um, there is a better approach, and that is combining multiple tests into a single executable. And the easiest way to do that will be to use a testing framework. Okay, so this is something we will look at in the next video. I will show how to use the same kind of tests that we presented here, but using a testing framework. So stay tuned and till next time, where I show how to use the testing framework. Thanks for watching and goodbye.